I had intended on taking us straight to the IPC veins because Con and Lick, they're very hardware oriented, and kind of take you in a different direction than we've been talking about more with the other veins. But to talk about Con, we have to talk about threads, and to talk about threads, we have to talk about Spider, and to talk about Spider, we have to talk about Gall. So it makes more sense to actually cover user space before we get into things that use user space. And so this is the end user zone of Urbit. At one point in the past, this was essentially synonymous with Gall and anything that runs through the Gall vein. And much as Arvo is essentially a dispatcher for tasks between veins, and this is what gives you the functional state machine OS, Gall is a dispatcher for long-running system daemons that we call agents. And these are the main way that people actually use Urbit, but there are some other parts of user space now, which include generators and threads. Where it's always anything that you do with Urbit from a console or from the front end is mediated by user space. The only things that you're really ever doing directly in Urbit is if you are Urbit eval, or you're passing in jammed nouns, this sort of thing. Otherwise you're always at least going through a thin layer of Gall, like an oxide around the surface of whatever you're looking at here. So to really talk about Gall, we're actually going to have to look at what agents are first. Gall is going to manage applications. It's going to manage their state. It's going to manage their subscribers. It's going to manage their queue of cards in and out. So we need to talk about agents. Then we need to talk about the vein structure. Then we can do a sideline into treaty and docket and what grid distribution and publication looks like now. And then we'll talk about agent wrappers, and then we'll take a brief look at dynamic Gall, which was the pre-January 2020 or December 2019, I forget exactly when it dropped, version of Gall, and go from there. Let's see. Trent says the first Clay homework problem involves the intersection of agents, threads, and generators in a way I haven't quite untangled yet. Do you want to refresh me on what that was?
Yeah, so the problem is to write a hood generator that pokes Kiln to read a file and count the lines and then make a new file for it. And so some of the examples showed doing that with threads, but then when I was looking through all of the hood generators, most of them were say generators that didn't use threads. And so I've been picking apart, like, how do you poke an agent from a generator, and when is it appropriate to use a thread to do that?
So essentially what you're going to need to do is issue like a Kiln card or something, and you're going to have to create a new card. Is probably the easiest way to do it. Like I think you should be able to do it without a thread, but if you do it with a thread, basically you're poking the hood agent with a new card, and you create that card, and you add a poke arm in hood to handle that case.
And so that card is just the output of the generator?
Yes.
Oh, okay. That's simple then.
Yeah. Kiln and hood is kind of where I was expecting you to rummage around to be able to do that.
Okay.
Obviously, the system's Turing complete, and there's a lot of different ways you can actually solve that problem. But I think that's probably the most straightforward, is to just do exactly what hood was doing for other analogous kinds of operations.
Okay, cool.
All right, so I said we had agents, we have the vein structure, we have treaty, docket, we have agent wrappers is worth talking about briefly, and then dynamic Gall. All right, so start us off here, agents. All right, so what is an agent is sort of a great place to start. So when you think about writing agents, all of you have written apps and agents on Urbit before. Like structurally, what is an agent?
A core with a bunch of arms.
What kind of core?
Specific. What kind of core? You're talking like zinc,
No,
gold.
like when you do it right, you're supplying. You have a bar cap, right, and you're supplying it a bowl.
Right. Oh yeah, I guess it's a door.
Yeah, so it's a door. Now that's not the only way you could set up an agent. And there's a lot of pieces here that we can kind of chop out because we don't need these internal definitions to look at like what it is. But it's a door. And what this means is that the way you're supplying the dynamic system information on each invocation or each interaction with that agent is you're putting that in, you're slamming that into the bowl. You're slamming the door with that bowl, and that's giving you ship identity and entropy and timestamp and incoming and outgoing subscriptions and all those other things. One could imagine other ways of setting up agents. One of the things that occurred to me when I was rummaging through the way that Gall builds things is, you could do something similar where there's sort of like a standard state noun or something that would have a certain shape, and then you're slamming this with the bowl and the state rather than managing the state separately, which is what ends up happening in practice. So you can imagine different ways of building this, but we do have a structural definition here as well. But it's this bowl with the structural definition. Has anyone tried to add arms to a Gall agent?
You mean like at the top level?
Yeah, just
No.
you
I'm afraid.
So you get an unexpected number of arms there. So by building this with this bar cab of this ket bar iron gate, we actually we're able to use this as a structural definition, and anything that uses this type when we actually pass out, this is a Gall agent. When we apply that kethep inside of our app file, that's where we are enforcing that it's a core of the same shape. It has the same arms. So there have to be 10 arms. Can't leave them out. You can't add them. We are going to take a look at shoe. Has anyone written a shoe application, a shoe agent?
Ages ago.
How many arms does a shoe agent have?
It's been way too long.
But it has more. Like I think it has 14 or 15. There's like a command parser arm and stuff. And so when you do it, when you build whatever you're doing, you actually have to do like agent shoe instead of agent Gall.
I don't know if
Yeah, so you have to do like agent shoe agent instead of agent Gall, and there's an expander that gives you a slightly different definition to interact with everything when you do it, which is we'll take a look at that later on and see how it does that. All right, so this is an iron gate. So now this is kind of the point where we can't dance around core variants anymore. We talked about this a little bit when we went back to the compiler, but now we basically have to deal with, this is what's called a contravariant gate. And the point of a contravariant or a contravariant core, the point of a contravariant core is that it is opaque. And what you want is something that interacts with this core to be able to be something coming in can be less specific than this interface, and the result can be more specific. And in practical terms, what that means is that we want this to be flexible on the sample that's being passed in. But when it's passed out, this is sort of the Platonic archetype of a gate, or excuse me, of the agent core. And any actual agent core we have is going to be more specific than this. So, you know, why we call that contravariant and why we call it opaque and everything is kind of getting into computer system type theory and why we would do that. But like the practical matter is we want gold, anything that nests within this core is either an iron core or a gold core that has the right shape and has a sample that can nest within it. In practice, what this means is we can use this as an example for building an actual agent core without over specifying the kinds of things that need to happen in these different arms. You could probably go back and rewrite this so that you're using a gold core, which is your standard core. It's like the, you know, it's the most open, least restrictive kind of core you can work with. I imagine that might leak some information, like might leak some type restrictions about the door sample or something that would be convenient to not have to worry about. But in practice, we're saying, you know, this is our archetype, and anything we do has to match it structurally, has to match it in terms of sample, but the contents of that sample we don't need to worry about, just that it has a bowl-shaped sample. Any questions about that? This is like sort of like notoriously muddy.
One of the most difficult things to understand when I was first learning about Urbit.
Fortunately, it doesn't really matter until now.
So the sample is flexible, which means that like as long as something can nest the bold type, it can be passed. Is that correct?
The
Like
sample is flexible.
Which means that something, as I understand, is that if we have a type that nests the bool type in a particular way, like suppose that there's something that's more specific than what's in bool, then we can still pass it.
Yes.
But the thing is, though, that the result is inflexible.
Right. The
Like,
result has to be the same shape. It has to nest.
So does it have to be like exact, or can it nest also?
It can nest.
Okay.
Now, in practice here, like I don't know what it would mean to have like a Gall agent shaped thing that nests, other than it is shaped like a Gall agent and it's a gold core instead of an iron core, which is what we do, right? We actually write our Gall agents as gold cores, and then we cat-hep them into iron cores. But from the perspective of like, you know, the app school level of writing agents, you actually never care about that. You only care about it here because here you have to have an archetypal definition.
And so why doesn't like let's say like we had like the same, that example we brought up earlier, adding another arm, why does that core not nest this core?
Does a core with more arms nest in a core with fewer arms?
I mean, if you have more stuff, it seems, well, no, I guess I see what you mean.
Yeah. I mean, it seems like we should be able to delete an arm and still nest properly, but I think in practice that doesn't actually work.
Yeah. I mean, I don't know how that would work, like implementation wise, like type theory wise, I could see.
But it may, you're right, it may nest and then actually just break in practice because you don't have the arm that it needs when Gall sets everything up. So we'd actually have to look at that. That would be an interesting experiment to run there. So let's take a note of that. Try to on fail is probably the safest because that one's not called a whole lot.
Yeah, maybe it's possible just omit on fail. That'd be interesting test to run.
Yeah. Maybe if we have some time at the end, we can come back and actually do this. But I will I'm just going to put this in the notes as a thing we could try. We can actually go back into hoon.hoon and look at how these things are implemented. It's inside of Mint UT, which is the builder from the Hoon AST to the NOC. And it checks the read write, the relative read write of the different pieces there. But it's actually just, as you'll recall, there's a variance annotation in the AST that gets attached to one of these cores, and then it's just literally checking the variance and has a what colon is branching on what kind of thing it is. One interesting thing, actually, this is kind of a trivial aside, is there is a rune that is, buckfaz. Anyone ever seen a buckfaz? This is one of the unimplemented runes.
A lot of the buck ones kind of blur together.
Yeah, but there is no, you've never seen someone write like a buckfaz whatever.
Yeah, that would look very weird.
Right. So
yeah.
but here it is, right? Like line 7800, there's a buckfaz, there's a buck zap, there's a buck tick, and there's a buck dot. And those are not actually implemented. If we search buckfaz, it's mentioned here in the overall layout, but it's never actually parsed or processed in anything. If you look through the parser stuff. So you could produce an AST that had this if you were building an AST manually, but you can't actually type it and process it that way. There's actually a lot of buck runes that are not implemented that way, like the buck recursion rune and some of these others. So yeah, there's some weird parts deep down in the system there. All right. So what does each arm produce? Almost all of these arms produce a quip card cab agent, and we've been using quip for years, and we know that it's basically a list item of state. So let's actually see what the quip definition is. And if you go look up the quip definition, it's a bar buck of an item in a state which produces a list of items and a state. It's almost so simple that I wonder why we even have this wrapper instead of just saying list card cab agent in each case. I don't know, kind of a funny definition. The problem is it kind of throws people off when they're working with it. But all right, so most of these return that. OnSave returns a vase because it is returning the former agent state ahead of an update, so you can onload it. And on peak, which returns the unit cage because it's a scry, and so it's going to behave like a scry in that regard. Everything else is quip card cab agent. It's a list of effects and a state change. If we look at what everything returns, so this input is specified with these bar sig values here. The output, and then the input is specified on each one tersely as well. But if we put all these together, then we can see two of these are not gates. They're just arms that actually build when you call them. Onload accepts a vase because it's an upgrade, so conceptually no problem there. On poke accepts a cage because you're trying to actually pass it a mark and then a vase of information for it to unpack. On watch and on leave are paths because they're subscriptions. On peak is a path because you're peaking, you're scrying to a particular value there. One of the things to keep in mind, right, is we talk about scries in two senses. and we tend to switch seamlessly between them without really resolving exactly what's going on. So when we, there's a sense in which, we start off and we're like, oh, we have a life and a rift and a ship and I guess I'm out of order there. And then a vein and a care and a whatever, right? Like it's a very formal, full definition here. And yet every time in practice that you use an on peak arm or you dot ket in Gall, like you're not passing it all that information, right? You're passing it a mold and a vein and a care, and then a notice to the value. And then if it's a sen X, you have to have some sort of mark annotation at the end to get it out. And in the first case, we're very precise about this has been bound into the scry namespace. We are making this commitment that this value is no longer mutable, and it will either be referentially transparent and this value exists, and here it is if you have permission to see it, or you don't have permission to see it, or you can't see it, and we're just going to let you know that it's failed in some way. Versus what from a Gall agent standpoint kind of feels fast and loose, which is anytime anyone requests a value, you just return that value back out. So how do we reconcile these two views? That is not rhetorical.
I mean, doesn't the path include a lot of that stuff, the life, not exactly the ship life rift?
So yeah, so basically the path is like this part, right?
Right. Yeah.
Yeah.
Oh, but doesn't it also have the care?
have we thought about binding this into a namespace? I guess there's a case too. I'm all out of order.
Not very hard.
So the way that we're kind of fudging this in practice is that because we're providing a timestamp when we make a request like this, we're just saying, here's the value at the current time. And we're sort of treating that as like a soft bind into the namespace. Like, yes, if you request this value at this time in the future, you'll get the same answer. Except in practice, you can't really request it at the same time in the future because the time has changed. So there's a little bit of ambiguity there that's been exploited for the practical nature of writing an agent, but still taking advantage of the affordances that scries provide you. I don't know. We'll see where that ends up in the long run, if the .ket revision goes through or not. But so that's our on peak. Our on agent and our on arvo are pretty similar, except we just have different kinds of signs coming in. And then our on fail, we're going to get a term label, and then we're also going to get a tang, which is an error trace, a list tank of our actual text of our error message there. Handling error messages purely as a text-based stack trace still strikes me as kind of odd, that we don't have something like an exception object that we're accruing information into and then dumping to text when we need to. But that's what it is right now, and probably for the foreseeable future, since I don't imagine changing that is anywhere on the roadmap. Let's see, other things to note about agents. So you probably noticed that when you build an agent, you can just have your arms and then close and then just keep going without a Tizgar or a Tizgal. Sometimes people put a Tizgal to explicitly compose their helper core before their other core, if they don't alias it or whatever they're doing. But actually everything inside of when Forward Clay reads in a Gall agent from app, it basically composes everything in it inside of serial Tizgars. And so the cores are just serially present in the file, which is kind of a weird build pattern. And to wrap up agents, let's take a brief look at libshu and see the way that it implements this. So, all right, so here's a shu Gall agent core with extra arms. So it's a bar tar, it's actually a builder. So we're going to send hep, apply it to an input rather than ket hep, apply it. It's a ket bar, it's an iron gate the same way, and then it just reproduces the logic here explicitly. I've never actually seen this default used for anything, where you actually do have the empty standard shu arms sitting out there like that. But basically, if you're doing a shu, then a CLI agent, you're automatically wrapping these pieces in there with this Gall agent alternative instead. I mean, it's a pretty simple implementation in that regard. Now, when we look at Gall as a vein, let's go to lol. Yeah. So the vein itself is not particularly complicated. It's about half the size of Clay or Ames. Most of the complexity in it arises from trying to keep track of a bunch of different queues and make sure things are routed to the right place, or I'm setting up an agent so I can apply changes to it so then I can return the effects back to Arvo and the whole system there. It feels to me like Gall has a very Chinese room feel to it, like Searle's Chinese room, where you take a message and then you go, you check the books and you apply these rules and then you pass the message back out. Clay feels that way. Like Clay sort of doesn't, or sorry, Gall feels that way. Gall doesn't really know what's going on with your agents. It is purely just a handler. It's going to set them up, apply the changes, store the state, and then do the takedown on the other end. And so it's going to use an embed pattern to accomplish that. We do have to consider Gall at two levels now. So we've seen what an agent looks like and why an agent is defined the way it is. But Gall we're gonna have to look at it at the vein level, which is managing top level state, like the set of running agents and queued moves for different agents, or queued moves for agents that don't exist yet. And then at the agent level, which is how does Gall manage an agent as a door and instrument it and call things in it. The thing that's going to simplify Gall for us is that Gall is landlocked. It does not have a runtime counterpart. So it's a little bit simpler to just talk about Gall. Here's Gall. Let's just jump up here. So we're going to see there are two sets of gifts and tasks and everything. One is the vein level operations, and most of the vein level operations, unsurprisingly, have to do with telling it how to handle agents, right? Like, am I starting an agent? Am I nuking an agent? Am I installing an agent for the first time via a load or something? Or I'm doing meta things, which are clearing or managing queues and subscriptions, and setting those things up that way. After that, there's a lot of bool information where we're setting up, here's the standard information we're going to pass in. So we're going to come around and we're going to deal with the important types when we run into them, because a lot of these, like, unless you're dealing with a Gall directly, you don't need to know what a Gall is. It's kind of obscure. We do need to see now. Let's go to the agent state and start with, like, what's the top level? What does Gall know? There's its, all right, there's its actual state. All right, so we have a system duct, an outstanding, a contacts, a yolks, a blocked, and a bug. All right. System duct is the set of outbound moves to other veins like AIMS subscriptions or remote agent contacts that you're sending somewhere. Outstanding is the set of requests that you know about that you haven't yet processed into whatever you need to. Contacts is the set of other ships with whom we are in communication. I'm presuming that we keep it here in state because we kind of want it memoized, like we just want a quick lookup rather than having to query it from some other vein to know that, but we keep a local set of that. Yolks is very important. Yoke is your set of running agents and the state that those agents have. Okay, so a yoke is an agent state. It's like, how do you keep track of your subscriptions? How do you keep track of the marks that it knows about? What desk is it running on? All this kind of information. Now, and then blocked it's the set of like if you accidentally poke an agent and you misspell the name or the agent hasn't been installed yet or something, these go in blocked. So every time a new agent is loaded, it goes back and it checks blocked and says, is this a key in my blocked map? And if it is, then it applies those prospectively. And then this is your debug printf config. Yolks, yeah, so yolks is the important one here. Now, we've talked in the past on Urbit. I don't think you and I have had this conversation in here, but there's kind of been a question of like, why can't we have an agent with the same name on different desks? Like right now, Gall, just every agent has a unique name. And so there's been talk about, how are we going to re-architect user space? Are we going to give every desk its own subdomain and use that as a security mechanism? What are we going to do with that? Right now, the limiting factor in a practical sense is that our yolks, our map of term to yoke, is indexed by a term. Right. So you can imagine a different world. I mean, so that is the agent name. You can imagine a different world where you have something like this, right? Where you're doing a map of pair desk term, and then you're actually able to keep track of agents with the same name. There would also need to be some changes in Clay and a couple other places, because right now we just identify agents by their name. And that's the only registry that goes in. But this is what you would need to change if you wanted to permit the same agent to run on different, or an agent with the same name to run on different desks. There's also the problem that if we did that on Urbit, someone bar merges from base to build an agent and they forget to clear the desk.bill, and now you have two agents with the same name that are both running. So you'd have to start keeping very close track of what's going on with your wires and your ducts and everything as you're routing things around in that case. So it's kind of a mess, and there's a reason, like, there's not a technical reason we haven't done it. It's more of a social reason of like, we haven't figured out how to make this a smooth developer experience yet. All right, so for every agent, then every agent is going to know about this information, and it's going to know about its bowl. Let's look at its bowl first. So that's this block here. So every agent gets supplied bowl in its door sample every time it's run. This also tells you why when you run an agent, you can't guarantee that you're going to get a different timestamp on cards, for instance, on wires. You're going to have the same entropy unless you are actually using the OG core and cycling forward with your random number generator, because the bowl is supplied once for a particular interaction with the agent. Like here's the bowl information. Our source and DAP is your agent name. Pretty straightforward. WEX and SUP are your subscriptions that you know about coming in, and the subscriptions you know about going out. Sky is Gall's side of managing remote scry bindings. So this is what Gall knows about. I have run grow, I've sent a grow card, but I also need to track in Gall what that value is, so I know how to do this. And then act as your change number, the serial number of actions that you've had up to this point, entropy, current time, load source. The only time that I've ever had to deal with act explicitly was in constructing unit tests for agents, where you want to pass it a certain number of moves and you have to update it to a certain state. And so you have to make sure that your change number is the right thing before you can compare these values to each other. Other than that, I'm not actually sure what's done with act. It doesn't seem to really be extensively used otherwise. Questions about the bull?
One quick one that I just noticed is aren't those first three variables the beak? Why is there an extra beak at the bottom there?
Because there's an extra beak. Yeah, there's just two beaks. Like there are two ways to get this information.
I see. Okay. Okay, so it's just another way of getting it.
I mean, you'd have to construct it right from, you do know hour, and you know term, which is the agent, but not the desk. So I guess what beak gives you differently is beak is going to give you the desk.
Yeah.
That you're running on. It does save you having to construct it explicitly, which you don't do a lot in user space itself, but when you're doing something like building a mark, you do need the beak because you're going to be pulling marks on the same desk.
Right.
And there's a lot of mark building that goes on inside of Gall for certain actions. So probably just a convenience in that sense.
And I do think, I mean, it is, I think, orthogonal sets of information, because you do get a little bit of a, what's the word, redundancy in that, like, the first item of the beak will probably always be the same as but yeah, the desk and the current version, I think, will be separate pieces of information. But minimally, you get the desk information, which you'll need in some cases. All right, thank you.
Okay, so that's a bull. And like, I mean, there's like a boat and a boar, these sorts of things. And it's like you're not actually going to care about these unless you're dealing with them directly. They're not used anywhere. It's like they are used for the set of subscriptions in bulls is their purpose. All right, so now what's a yoke, right? So a yoke is the information that Gall needs to set up and run your ship. There's going to be maybe, okay, so at the top level in Gall, there's a Mo arm, which is your Arvo move handler. So you've gotten a move. What are you going to do with this move? How are you going to process this move? And then there's a Gall agent core handler. And the basic pattern is the vein receives a move, or receives something. It doesn't necessarily receive a move. So I guess I should not exactly call this, but it's like an external event handler, I guess might be a better way of saying that. The vein receives, a take or a scry or a whatever it receives, not load. Take, scry, call. Is that right? I'm trying to remember what that other one was called. So it receives like something coming in. Then it's going to call Mo to handle the details of it. And then if it involves an agent directly, then AP for specific agent. And so AP is going to be used with the yoke state to set up the state of an agent. Basically, Mo calls typically resolve into AP calls. So Mo ends up setting up all the framework and infrastructure ahead of AP handling a specific agent. There are two main abet patterns in Gall that we're going to run into as a result of this. There's ones that are prefixed with Mo, and there's ones that are prefixed with abet or with AP. And it's fine. It keeps you oriented with what you're doing and where you're doing it. It's actually quite, it's a pretty legible vein, right? Like Clay, I don't consider to be a legible vein. For instance, Ames is pretty complicated. I think Gall is actually surprisingly readable when you get down into it. I mean, it does have like these kinds of like to-do documents in there, but for the most part, okay. So the control duct, I was going to figure out what control duct and stats were, but I never bothered to here. But basically, you're going to get a unique nonce for each rebuild of the agent, and you're going to get an app-wide watch nonce. So just a number, just an arbitrary number that gets associated with it. You're going to have a set of incoming and outgoing subscriptions. You're going to have, and then bore is related to the outgoing subscriptions. You're going to have the most recently loaded code as a noun. Okay, so this is what happens when you do an upgrade. Ford, Clay receives the upgraded agent over Ames or Finney, both. And then Ford builds it, and then it hands it to Gall as a noun and says, okay, turn this into an agent. So from Ford's perspective, Clay doesn't care what it is. It's a noun. Ford is happy to build it into a noun, but it hasn't done any validation on it except that it is a valid instance of executable knock. It's like it's well formed. And then now that we're actually passing it into Gall, Gall is going to have to say, okay, can I actually build this? Like, can I use this as an agent? Then you're going to get the agent core either as the agent type or as a vase. The compilation source, the set of marks. And then these are scry bindings and open remote scry requests outgoing. So Sky are scry bindings, and then Ken is your set of open keys that you're keeping track of. So probably the best way to do this is to just run through a life cycle of this with a few of these. So let's look at like scry. All right. So gosh, do I even use it here? Just like, I want to find. Okay. Do you remember what a roof is? This is going all the way back to like the second or third lesson.
It's like context for scries, isn't it?
Yeah, it's like a gate that handles scries. So when you build, when Gall is mature, like you've produced Gall, one of the things you supply to it when you build it is you give it a roof, which is its scry handler, scry context handler. And there's nothing special about that. It's just a regular, mock style. I know how to resolve 12s into something in the system, but it is supplied here. And so when you have any agent scry into Gall, it's going to come via whatever the appropriate roof was. That roof got called by Gall on some other agent or by some vein like Con that's looking into Spider, for instance. But somehow that scry got resolved to this scry arm of the Gall vein. And it's going to supply the regular standard information, return the regular thing. In practice now, we have to do a discrimination between scries that are meant for Gall and scries that are meant for agents in Gall. right? Because you can scry, you can ask the Gall agent for information, and you can scry and you can ask. Yeah, so you can ask it as a vein and you can ask it as an agent. And the way that we're going to distinguish here is that we're going to use buck here. And so in practice, what that's going to look like is, let me see if I have one ready at hand here. Yeah. So for instance, if I do a scry that looks like this, send GT, like that double faz right there is a buck scry. There's a, so it's an empty term there, send buck, basically. And that is telling Gall that this is a scry into the vein, not into the agent. So these are the vein level endpoints. And so what we're actually doing here is we're checking with this what dot, is the head of our path empty? If it is empty, then this is a vein scry, and I need to handle it as a vein scry. So if it is a vein scry, because this is a what dot, we keep going down. All right, we keep processing things. And so we'll take a look at those in just a minute. If it is a scry to an agent, then the first thing we check is, are we on a ship and are we scrying by the case of time? Right. So we actually don't permit other kinds of scries here. Like we are checking, are we on our current ship? We only support .ket and scry calls on our current ship in this sense. And so if you wanted to change remote scry to work more like a .ket, for instance, like a blocking operation or something, this would be the sort of play. This would be one of the places you'd have to change things. You'd have to say, okay, we're not going to do this fence on what's coming in. And then we do some checks like, do we actually have it? Is the path, is the rest of it actually a path, etc. And then it goes into Mo, the Mo core. Otherwise, like if it's actually valid, we know what it is. Okay, we're going to pass it to Mo with the information that it needs.
A quick question here, Neil.
Yep.
Does this mean that we always, like, if you're doing a agent scry, like the ship always has to be our? I mean, that I know, but it always has to also be now. Like I keep forgetting the name of it, the care of the case. It always has to be now, it looks like, or else it won't work. Is that right?
It is doing a validation on that, yeah.
Interesting. Okay. Yeah, so this is kind of what you were talking about earlier with, like, yeah, this extra information here where we do include that, where, the referential transparency thing, the whole idea is that, like, you'd be able to query any time or get something for it, but here it's like you can only request now. Like if you do anything else, it'll just give you an empty.
Yeah, so we're sort of like getting around the scry namespace by saying, well, you can only ask for it right now.
Yeah. You ask for anything other
like
than
it is referentially transparent, but I'll only tell you right now.
Interesting.
So if you wanted to get around that, what would you have to change?
You'd have to like store historic state, wouldn't you, or something? Like,
yeah, you'd have to have like yoke or something would have to store previous cases of things you wanted to scry.
Yeah, interesting.
Which you could do, right? Like, I mean, you could imagine. I mean, this is like where, Ted at reassembly is like, well, we don't know if we're always committed to the Gall model of running user space.
Mm-hmm.
It's like, I mean, there's a lot of tweaks you could make within this that would make Gall behave pretty differently from what it currently does.
Mm-hmm.
There are probably pretty good reasons for why we're just saying, you know what, we're only going to handle synchronous .kets.
Mm-hmm.
I mean, there are good reasons. I can think of several good reasons, but
yeah,
like,
interesting. All right, thank you.
All right, so then it goes into MoPeak, and we'll take a look at the MoPeak stuff in a minute. Otherwise, we do a bunch of care checks, like is it a U care, is it a D care, is it an N care, an E care, whatever you have. So you have a whole list of like, D is get the desk of an app. So, if it's a D, then we check, do we have it in our yolks? If we do have it and it's running, then we can pass in information like this, so it only gives you the desk of a running app, for instance. E is your set of running apps. F and N are nonce stuff. T are your remote scry subpads. U is like an installation check. I'm actually curious how they handle U. So U, first we check whether or not it is in our state. Like, do we have it? Okay, and then we check whether or not it's live. So our proxy for check if installed is, do we have a state for it and is it currently live? Which for certain versions, like for certain values of the word installed, that may not be exactly what we think it is. Right? Like you can imagine I have it installed, but it's not currently running. Being a valid sort of question you could ask. But let's see. There's some others, like you can remote scry files using GX, for instance, or get hashes of things with Senzi. Anyway, there's a bunch of them. Agent scries. Okay, so when we go back to agent scries, things get routed down here. At this point, when we make this call 2153, what have we guaranteed? So we've checked that we have a route to it, or we've constructed a route. We've checked that we have a path, that we actually have like multiple values. We've checked that we have it in our yolks. We've checked that it is now. We've checked that it is our ship, and we've checked that it is not anything else. We have not looked at things like the care. So you can actually scry with any care into an agent. Most of the time people do an X or a Y, but you could get exotic with it if you wanted to do other kinds of things. There's no validation done on those up to this point. So let's go to Mo. We're going to do a Mo. All right, so Mo is a regular nested core pattern. It has an abed and a bet and everything. Some of these don't worry about the abed because, like with a scry, there's nothing to do, right? Like there's no setup that needs to take place. So we need to just find Mo peak. And I could search, but I'm just going to scroll and see if I can find it. These things are not quite alphabetical. They're like pseudo alphabetical. All right, here's Mo peak. So what does Mo peak do? Accepts these values, returns a unit cage, no surprises there. Now it checks if it's live. If it is live, then it's going to call a bed on the AP core. And then we're going to peek into what we have there. So now we need to jump over to the AP core. A bed is going to set it up for evaluation. We're setting it up with the agent name and the roots, right? The information that we want there. And then we're going to look at our Veb was, I think, a verbosity flag, if I recall, and then the care and the path that we're looking for there. So let's go to AP. All right. So you never get to AP directly. You always go through Mo to get to AP. And AP wants some standard information here in its bowl. And the embed is just got by yolks state DAP. So look up the current state and apply a yoke, which is what loads the actual agent state. An agent is a door that has a bowl that has state. So this is what's actually pulling and setting up that information. and producing an AP core with a tis dot. So we have AP core is a reference to dot. It's the thing we're currently in. It's the core we're currently in. I don't know why it's a less instead of a less tar. But so then we're updating our current context. We have a name, we have the routes, we have the yoke, which is our state, and we have the ducks that are associated with it, and then we're returning that value, AP core. And then we're going to call AP peak on that result. So AP peak then additionally takes a care and a path. And now we're going to process in here. We're going to do all this care and path stuff. Okay, so ultimately what happens is we need to call the on peak arm inside of this agent core, right? Like we know that's where we're going to end up. So AP peak is doing some checks, pull the mark off. And then here is, that's the moneymaker right here, 1268. AP mule peak, bar dot on peak, AP agent core, care tile. All right, so AP agent core is the agent core with its current Boolean state. It's the thing that was basically set up by AP abed a moment ago. And I think it's actually just an arm. Yeah, it's an invocation of the current bool against the yoke that was set for the AP core just now. So nothing strange there. And then we know that it is an agent-shaped thing. We know it's a Gall agent, so we know it has an on-peak arm. So we can call that on-peak arm. However, why do we do this in a bar dot? Why do we do this in a trap?
In case it fails.
Because it can fail. And we don't want a failure to take down the whole system. Do you remember what mule does? Way back in the day?
Doesn't it run a trap, and like if it doesn't succeed, it will just like give an error instead of actually crashing the system?
Yeah, it's like it's our virtualizer. Right? So it lets us run a trap and produce a success. Or, well, it's either a success with a code, or it's a failure, which is, and then it has a list of, it has the error trace stuff. AP peak mule, or mule peak, I guess. All right. So this is going to actually run this really cool line here. All right. So talk me through this line. What is this line doing? We're getting a bar dot. It's the thing we just, it's the trap we just got. Then we're going to 9201 it.
It's been too long since the knock stuff, Neil. I forgot what is a 9 a run?
9 is pull an arm and a core.
Okay, pull the arm.
Or add an address. Yeah. So we're going to grab and execute the trap, and we're going to do it with the roof scry handler that's associated with Gall. And then mock, because it's virtualized, gives you back a pair of a result code based on the kind of crash you had or a success and the result of the value. And so in the case of a PAM, we've succeeded. So we return back out that each, and then it unwraps everything, gives us back our unit cage. And in the case of a failure, then we deal with the crash. Like, I like this. Like, this is actually pretty cool.
It seems like a good opportunity, and tell me, Neil, if it isn't, to ask this question, which is I see like maybe every couple of months someone in Hooniverse or Battery Payload ask a question about like scries crashing. Like I think people want to know like what scry endpoints does this agent provide. I think that that's what they're looking for, but like it feels like the way that this is handled and the fact that you can't get that information directly is why that's not possible. Do you kind of know what I'm talking about?
Sort of like why don't I know what the valid scries are?
Right. Like here's an agent. I just want to know what all the scries it can handle are. But like you can't really do that because if you run a bad scry on it, it'll just crash. But that's indistinguishable from like running a valid endpoint and it crashing, right?
Well, in the case that you get the SIG back, yes. If you get a SIG back, then you know it crashed. For some, like, well, I guess that's not really a crash. That's just a failure to read, or it's like a guarantee that this value isn't here or whatever. Yeah.
Mm-hmm.
Yeah. So it's actually kind of a hard problem to say, like, prospectively, what is the field of scries that will succeed into a given agent,
Mm-hmm.
right? And like, why might they fail? And unless you're running it through a handler like this, then you just get the raw crash.
Mm-hmm.
So as something of an aside here, I've been thinking a lot about trying to use a mock style meta circular interpreter to build like a try catch exception handler. That would actually like be able to give you more like better information about like why something failed. And I think and I think this is actually the same problem as breakpoints. Like I've been chewing on this for like 2 months. I had a conversation at reassembly that's been putting my mind down this road, and I think that this is actually the same problem in Hoon. And it has to do with the way that we're handling things in the metacircular interpreter. So there's kind of this cluster of like can we do an exception object that's more complicated? Can we handle things at a breakpoint? Can we try catch code? Like just sort of like more elegantly deal with all these things. And it's sort of like if we had a mock, like a different mock. Like I'm not saying we want to replace mock, but we want something that is an interpreter either next to or on top of mock that does this kind of stuff. I've been playing with it. It's something I want to work on after Core Academy's done and see where that goes. But that's sort of part of an answer to like, yeah, we can't define in advance what the scries are that will succeed, because that's an open-ended problem. Like that's a halting problem kind of question.
Mm-hmm.
But we can. There are certain kinds of things we can expose. So there's a project I've been working on. I have not been working on. There's a project I started in April and have not worked on since then. Would be the more accurate way to say this. That I actually think will be really helpful to have. No, I don't. I want to look up one. Sorry, I'm trying to figure out how to get it to open one file into my workspace here. This is Opal, if you remember Opal.
Is that the name of the project?
Yeah, Opal was the idea. The idea is that we should be able to have an agent wrapper, a stateless agent wrapper that automatically wraps your scries and exposes everything by face. And I think this is actually viable. I think you actually have to drop into vase mode to get the faces. Like where I actually stalled out at the time was trying to get the set of faces that are known inside of the state. And at the time that was just like too complicated of a project for me, so I set it down. I think I could actually solve this now if I set aside some time to do it. But this is sort of saying like, let's just make the state scryable in a standard way. And I think that would also respond to some of the kind of problem that you're referring to with newbies upset about .cats.
Well, I think it's anyone who is just in the general space of like wanting to know what information an agent provides, right? Like even if they're trying to write an agent wrapper or something, and they run into this problem, it just seems like I see it every couple of months, maybe even like maybe less than that, maybe like once a quarter or something. But somebody like wants to do it, then they can't really do it. But if they had something like Opal, I could see how that would be much easier, because you just like look at the faces of agent state and you say like, here are the things that will be exposed, like here are the tries that will be there. Okay, interesting.
Yeah. So, you know, maybe I go back someday and get it done, or someone else picks up the torch and gets it out there. I think it would be really nice, but.
And how also would the try catch help with this? Would it just expose more information on like, if it does fail, why did it fail?
Yeah, the idea of the try catch, the breakpoint, the exception handler stuff would be that when something fails, you would be able to get something more specific than what Zapcol exposes to you. Like you'd actually be able to get like a core dump, like what were the values of these things when it failed, right?
Not
Instead of
like
like
it failed here.
Yeah, instead of dumping a bunch of sigpams, which is what you have to do now, you could actually get like, what was my state when it failed, and can I query my state? So
interesting.
Okay. That's a peak scry handler. That one's kind of more straightforward. I want to walk through. Let's see. Okay, so we end up with something where it's kind of similar here for a lot of different kinds of move injections, where so for instance, this one is if I want to nuke an agent, if I run bar nuke, then what actually happens is I get a kill nuke, which goes to a poke nuke, which passes to Gall, a nuke dude, where dude is your identifier for what you're trying to do. This goes into the call arm, goes to the Mo, goes to Mo nuke, goes to AP, goes to AP abed, goes to AP nuke, and incidentally uses AP ingest to set up the event. AP abet and then Mo abet, and it sort of wraps things down, does the work, and then unwraps them back out into the state that you need. So this pattern is really common here. And so if we go look at, AP nuke is what's doing all the work here, which is that we actually are just systematic. We're going to turn over all the paths that we know about. We're going to kick everyone. We're going to leave everything that we have. And then we're going to somewhere here, we're going to kill our yoke info. Where are we killing the yoke? Tap by boat yoke. That might happen in the AP ingest. Which gets called for a lot of different kinds of things. Okay, then that calls a specific arm in the case of things happening there. But like this is the pattern for Gall stuff. A poke is interesting too, in that, let me give you the text version of it, and then we can look at a couple of these arms here. So like what happens with a poke is you get a move injected somewhere, right? And we actually, a move can be injected by the runtime. It can come from another agent. It can come from a vein. Like we don't know the origin of this move. That's our poke. But a deal, it goes in as a deal. So that means it's going to go to an agent. Then it goes to Mo handle use, handle local if it's a local agent. If it's not a local agent, then it has to figure out what to do with it. And then it's going to prepare to call AP by applying some state information like the yoke. Then it's going to AP abed. It's going to AP apply, which is a dispatcher that's kind of interesting. Let's see, AP apply. based on the kind of effect you got, you're gonna dispatch to a certain thing. So that's gonna dispatch to AP poke. It's like exhausting. You're like so many calls deep in this. So AP poke then is going to do the same bar dot thing, but it's going to do it with an on poke because you have an on poke. And then with this AP ingest here is going to queue a poke act outside of whatever happens inside your on poke arm. This is because the poke act is definitively the first move that is returned, that's evaluated from a poke. There's a poke act that goes back. And so this AP ingest handles queuing that up. Then that is going to go down into, there's handle results ends up with notifying watchers, and handle peers ends up notifying watchers. And you just end up walking up and down this tree, and then you finally, at the end of the day, you AP abet, and AP abet is going to update the yoke's state with the changes you made. So you made these changes in this copy of AP that has a local yoke. So now we have to put this back into our global state, like our Gall state. Now this is how Gall updates its state. And then we have to dispatch along our duct, our hen duct, all of the passes that we have coming out of this. And then we explicitly update Mo, which is our move, with our current states and the moves that need to go out. Then we have to go back out to Moabet and finalize over here, which gives a Gall payload, which is the thing that goes back to Gall and actually updates Gall. Let me find the original of that. Yeah, so this is now the TISTAR of Gall payload is this Gall state itself. All right, kind of complicated, but like as you look at each step in it, you can see why that step is there and why we're going through these. Now, another aspect of that is that when we looked at when building things with Ford and getting subscriptions and everything, what actually governs which agents can run on a given desk? How do you know what agents can run on a given desk?
The bill.
Okay, so the bill. All right, so let's see if the bill is mentioned here. Bill is not even mentioned in Gall. So where is bill handled?
Oh, Clay, maybe?
Okay, so let's go to Clay.
Oh, there we go.
So yeah, we get a desk bill from Clay. And so what happens is in Goad, once we've processed, is it live? Is it not live and everything? We're going to build. So here we're actually building desk bill with a var. If you'll recall, a var was our general file. Look at a file, give me the contents of file. It's gonna put the bill together, and then ultimately it is going to issue looking for the. I think this is just farther down. Oh, here we go. This is what I'm looking for. It's going to issue a load card to Gall for each, for the set of agents that need to be built on that particular desk. So this is what is actually installing an agent or installing an application runs through Clay, not Gall, to handle that. So backing out now to treaty and docket. All right, so we have FASApp treaty on landscape, right? So these are actually on the landscape desk. FASApp docket. All right, so back in the day, if you wanted to install an Urbit application, you had to bar merge off of home, because home was all you had. And you had to manually copy in the source code from GitHub and sync it and bar install local. I don't know if it's bar install. I don't remember what it was. But you had to start this desk. This was before desk bill. Like if it was just like whatever was in, I think if you bar installed, you got like everything, if I recall correctly, that was in app would start. Like there was no control over it, but you were only running things that you had actually gone and retrieved and set up here. And so in that sense, installing something just meant putting it in Clay and telling Gall that it was alive. Right? Like that was it. That was the whole process there. When Grid was released in September or October of 2021, then you had the ability to install someone's remote desk locally, and the system that was put together for this was Docket and Treaty. Right now, formally, these are Tlon products. I'm not sure if that's going to stay true or not. There's kind of been some noise about like, well, maybe this is core infrastructure. I mean, like de facto, it's core infrastructure. But anyway, there are these two apps, and they're distributed on Landscape for historical reasons. Treaty is going to handle publishing and advertising application desks. So it's sort of analogous to Bar Public Desk, which you've seen with Clay before, just mark everything on a desk public so someone can talk to it. But it also does some registration and advertising. So Treaty is how one ship, if you go into the Landscape front end and you type in a ship and it searches for what they have available, it's talking to someone else's treaty. And so if you go to Landscape and talk to, do I have a Landscape? I do have a Landscape. Let's go to Treaty. This might be a disgustingly old version of Landscape, actually. Where am I here? Let me just open App Treaty somewhere that I know is more up to date. I guess any Zod I have recently would probably have that. Nope, that one's not recent enough. App. Okay, there's Treaty and Docket. Okay. All right, so so here's Treaty. All right, Treaty is actually a really nice file. I like Treaty. It's very, very well constructed. It is built around an analogy of having an alliance with someone and having treaties. And the treaties are like the things you know about what you can install. Sovereign are like the things you have published locally. Allies are like the people you know about, the people you've already contacted and you kept track of. Anyway, it works moderately well as an analogy. No real complaints about it. It has a few, it's not a terribly long agent, but it has a few helper cores at the end here. Notably TR and SO. So SO are my local treaties that I'm publishing something, for instance, right? So if I want to publish a desk, what I have to do is I have to tell Kiln to mark everything on my desk as public. And I have to, there's some other stuff that I have to do, like tell it that it's a sovereign treaty is like a local it's like what I publish locally, right? So if I publish something locally, it becomes a sovereign treaty and gets registered here. And then if I want someone else's information, then I have to request it using the treaty engine here through watches. So I set up watches to someone else and go look around and find what they have. And as an agent, it's actually pretty straightforward. Like it's not long. All the front end stuff with grids, landscapes, display, and everything is all in JavaScript. It's all handled with JavaScript. But treaty's just sort of nice and clean. Docket is what actually handles retrieving, validating, and installing application desks. So treaty publishes and advertises desks, and so it's what you know. Docket is what actually retrieves and installs desks. And it's a little bit more complicated of an agent, probably maybe about 3 times as long. We want the install in the charge engine, CH. And so to actually install something, all we're doing at the end of the day is we're passing a kiln install for a desk for a particular remote ship. And then Clay is taking care of all the regular things that it would take care of with installing that remote, making that available. So no real mystery there. It's using system affordances. And honestly, a lot of what's going on with treaty docket is in the front end, which is just instrumenting it for you because the agents are pretty straightforward. All right, let's talk briefly about updates, and then I'll run through wrappers and dynamic Gall quickly, and I think we'll be done. I don't think we're going to have a long lesson today. All right. When Gall receives a new agent from Clay, it needs to do a few things. And updates and installation actually look a lot like each other. So it's going to call the on save of old agent. Then it's going to call on load of the new agent, which is like that, which is code, right? It's that one that we have there. If there's any crash, then the whole event crashes and the old agent continues to run. And since all of the agent updates are handled in a single event, this means that any agent crashing aborts the entire commit. This is why you have to bar suspend things before you can do a system upgrade sometimes, like a bar bump. The order that these would happen is call would receive that load move from Clay. And let me find Gall again. Yeah, so we pass in, we build an agent, we pass the agent in, and then that goes to call as a load. And so load here, you can see there's a mo core, there's a mo load, there's a mo abed. So there's no abed because we just have the state present. And then we load and run whatever's in mo load. So mo load is our pretty mechanical operation there. Mo load takes a list of agents and is just going to turn over this list, or I guess it doesn't turn, it does a trap over this list couple times. So yeah, so the first time it turns over everything here, which is just runs a receive core to update the core for each one of these. And then it is going to get the list of agents that need to be shut down and shut down those agents. If that is successful, then let me see where it calls AP here. Anyone see the AP abed here? Just trying to get the order of operations right out of this. That might be in mo receive core. I don't see a separate call there, so it must be in mo receive core. Yeah, so mo receive core Okay, checks if the agent's running. Okay, this is where all the AP stuff is. This is where all the AP stuff is. So checks where the agent is running. If it is running, then we have to call in a bed. We have to call a reinstall and then a bet on that. So we do that in 3 stages here, and then we clear our queue, which is looking at previously queued pokes that were queued up before we set this up. And then we update our yoke state with like what we know now because we have a new agent, everything, and then we run this down. If it is not live, then we can just go ahead and build it and pass it out. We don't need to do any special handling in that case. AP upgrade state is probably the other one that's really important here because this runs an on init and an on load or an on load, depending on whether or not there's state there to handle. And it runs it on the maybe vase. The maybe vase comes from, oh, that's passed in, but that's basically like, is there an on save? If there's an on save, then we call on save, we pass this vase in. If there's not an on save, then we're just going to call on init and run on init. Those are our 2 paths there that we can end up with. And then we pass back out. There's like a mo idle that it runs through, which puts it to sleep if it's in the kill list, which means that desk.bill had it previously and does not have it now. And then we finalize our moves and state changes out back with a mo bet. So pretty mechanical, just the details of how do we actually wrap up an agent, unpack it, re-implement it, everything else that we need to do. Let me, okay, so what I would say about agent wrappers, I don't need to show you code for a minute here. So agent wrappers are things like debug, and they're a tool that lets you wrap additional handlers around an agent core. For instance, debug wraps the internal Gall agent with new functionality by catching pokes and peaks. And then if it doesn't match something in the debug handler, then it redispatches back to the normal arms. The downside of this is that if you have an arm that has the same name, excuse me, if you have a scry or a poke that has the same name as a debug scry or poke, which I've actually run into with scries in particular, then debug breaks your agent because it catches it before the redispatch takes place there. There's an old piece by Wikram Rikran from last year's assembly, 2022 assembly, about agent transformers, where he talks about the problem is your agent transformers, your agent wrappers have to be stateless, because if there's any state, then things break in interesting and difficult ways, because now you have to store additional state for the transformer. And if the transformer is later moved, then removed, then you have a bad vase when you try to do a state transition. And it just gets to be kind of a mess. Like, so stateful agent wrappers can be done, but they don't work very well because of that, which is a thing to keep in mind with that. Let's look briefly at the debug wrapper, the libdebug component there. All right, so let's look at lib debug. All right, so what libdebug does is it defines some additional pokes because you can get information. If you've never done this before, if you've never really used debug, you can do things like this. So you've all done my agent less debug. You've all done that. You can actually pass in things like code that you want to evaluate against the state. Like I could write an arbitrary hoon here and it'll ream it and then evaluate it against the vase of the state and give me that value back. And you can ask it for information about the bowl. Like you could do something like this and get, like what is my set of outgoing subscriptions look like? You can do some neat things with debug that are sophisticated in terms of what it would allow you to debug in principle. But the way that this is actually implemented is you have an agent, so you apply this agent agent debug to your agent, and for the most part, it's pretty similar, except it turns on debugging, and it arms that don't need any changes, like on agent, it just does like a Tizket pattern and passes the cards and the state back out, like no change, no additional thing. For things like peek and poke, it actually catches them at a different level here. And so if it's the wrong shape, then it gets caught, or the right shape, then it gets caught with the debug and passed in here, and then pokes get handled the same way. So if I wanted the state information like I was looking at a minute ago, this is how it's actually going to do that. It's going to take the argument that I made. So it gets the state as a vase, it gets the argument. Trying to see where we actually get the I guess product. Yeah, wow, actually, this is doing some sophisticated stuff. I didn't realize about this. So it checks whether it has a debug state scry endpoint, and if it does, then it uses the agent's custom vase, debug vase, in place of the on-save vase. And it does that with this mule right here. That's actually pretty cool. And then otherwise, it's going to do a slap slop on a ream of the grab, which is the text, like I did text value. So it's going to do a slap slop on that, and then give you this value back there. Yeah, I mean, it's neat. Like debug is neat. Agent wrappers aren't broadly used for some good reasons, like Wickham outlined, but when they're the right thing, they're actually pretty cool. And then finally, let's talk about dynamic Gall. How would you feel if someone gave you this as a Gall agent?
Be epic. I love it.
So this is what Gall agents were when I learned Gall. The names of the arms are the name of the move or poke hep mark that was coming in, or the subscription, and everything else was like standard. There was like some standard handlers for subscriptions and other things. So this was the old egg timer app. Like you've seen the egg timer app, you probably solved a version of it at some point in your Hoon experience. But this is what it was. Like if you poked it with a noun, then it was going to return a list of effects. And this is our cab. This is this lusgar.buck, which is a little scary to throw at someone who's brand new to Hoon. And we're returning like no changes, and oh, I guess that's a buck cab. So this is a weird way of making a list, actually. That's a weird way of making a list. I wonder if we didn't have Col Sig yet.
I do this all the time.
You buck cab sig?
Yeah.
Oh, okay, cool.
Like if there's like one item in the list, then I do this pretty frequently, because it's like the second part of the expression is way bigger. You know what I mean?
I mean, it's terse. It's terse, yeah.
It's a little weird, but I do it. I've used it at least half a dozen times, I think. Maybe even more. So.
I mean, I guess I wouldn't have any objection to it at all if something like this were in front of it.
Yeah, it tends to be like for it to work, it generally has to that has to be somewhere close by.
Yeah.
I also get very confused, but yeah.
I mean, the one that I really hate more than anything else is this one.
I don't really, yeah, that's pretty rare for me to
Trailing
use.
sig.
Yeah.
Well, because it messes you up. It messes you up because you're reading this thing and you're like, why is my tuple breaking? And then you look closer and you're like, oh, because it's not a tuple. You know, it's a list of tuples or something. So, and then the wake, this is what you get back from Bane, which is Bane regularly sends a wake. And so the wake is just it's the same thing. We just sig pam and return in this case, like what's effectively a tick this. So this is the Gall of the ancient past. Phil has said that he thinks that we may have a version of dynamic Gall again in the future. Like there are benefits to doing it this way. And so we might see some revival of this idea at some point, but you know, there it is.
What were the primary motivations for moving? Like what, like briefly, what are the advantages and disadvantages?
Well, at what point do you need to know what a mark is?
I guess
Right? Like if
there.
your mark is defined on your desk, you actually like you kind of have a problem. I mean, this was like before we had multiple desks, or you know, like no one was using multiple desks. You were just doing it all in home. But you actually have a problem when you're encoding the cage information into the name of the arm. Right? Because if I want to pass in something that is a valid operation, but I'm passing it in under a different cage mark label, it just breaks here.
So is this like the case where, like I'm thinking about landscape, for example, they have a lot of different marks that are the same. Like they ultimately have the same name, but there's like, you know, the mark name -1, you know what I'm talking about?
Yeah, so you get that kind of stuff.
Where it's like you couldn't really, like that would break, you wouldn't be able to use the dynamic mark stuff for that because like when you actually enter the type coercion, they're like fundamentally different, right? Like the mark would not be as you would expect.
Yeah.
Right. Well, yeah, I guess if you're doing static ones and you're actually doing the destructuring within the arm itself, you at least can pass it to the arm and see where the crash happens. Whereas here it's like it happens like as you're calling it. It's like not even able to compile. I think that's really the issue. I can imagine for one of those landscape marks, you wouldn't be able to do that.
Yeah, so
it's
like,
mostly with mark stuff. That's the big advantage to using the static arm set that we have now.
I think, I mean, I don't know if that's most of it, but that's part of it.
Hmm.
There was probably some document written at the time that explained it in great detail that has just been lost to history. I mean, if someone wants to go dig around in Urbit dev and see if it's there, I'll tell you, it was like December 2019. It was in that era, probably a month plus or minus from there.
Okay.
Might be an interesting archaeology project if anyone's into that. Your assignment, your homework for this one, I think will be pretty interesting, which is to build an agent that's a Gall-like agent handler. So you'll be able to make tiny toy applications that just have 3 arms. There'll be an on init, an on poke, and an on peak. And then your agent is just going to be a Gall-like dispatcher. So it's going to run inside of Gall, but it's going to behave like a Gall. And instrument these tiny agents. So it'll be like implementing 5% of Gall, but with the model of like you already know conceptually what's going on with all this. I think that'll be a fun one. Any other questions? If not, then we only have 2 left. So see you in the next couple weeks.